Okay, I hope you'll be able to create a model like that. So by using that simple model, I'll show you how we'll assign load. Then I will show you how we'll analyze it and how we'll design it. Okay, so before going a big project, we'll complete this a small work so that you can understand how this software work actually. So to do it, when everything is okay, our modeling is okay, and I believe that you will be able to create this model because already we have completed that. We have defined all of our loads in our previous lecture. So now what we'll do, I will assign load here. Okay, so to assign load, which types of load in our previous lecture I didn't show you that which load when you will select from here. I just apply random loads here. I mean I just wanted to give you an idea that how we'll use this software actually. Okay, so from this lecture we'll go for how we'll design and analysis and design a project a step by step. So first of all, I will apply self weight. So to apply self weight, I'll select this option, self weight, first of all. Okay, so after here the self weight, I will click here load definition. Otherwise you can click here go and load definition as previous. So and what will be selected here, that will be applied it here also as a load. So I'll click here load definition. Now I'll go for self weight, and in our previous some lecture already have applied that. Again you have to click here for whole structure to assign self weight, because self weight will be applied it for whole structure. Now I'll click apply. Okay, and when you will apply a dead load, you will see a symbol here, PZ. That means load in Z direction, and what is it? It is self weight. Clear? Now I will also, if you want to, it's done actually, so I'll close it. Now I'll go for another load. So what is that? I'll go for, let's say, dead load floor finish. Okay, I'll go for floor finish. So to apply floor finish, I'll go here, load definition again, and from here we'll go surface load, and here, so what will be our floor finish? Let's say our total floor, I'll double click here, I'll get a calculator here. Our floor finish will be 25 pound per square feet. Okay, so I'll divide this value with 1000, and our value is 0.025. so here I'll click OK. Sorry, I'll click here and double click. So it will be okay. We know what will be the value. This value will be 0.025, and it will be minus, obviously minus because downward. Okay, so the value of this value will be downward, and this global direction. Then click add, and where we will apply, just click here and select this panel. So you can see the panel 132 number panel we have selected, and then click apply. You'll see a load have been applied at our, and what is the value? 0.03. It's showing 0.03. It's showing value for two digit after point, but our value is actually 0.025. And here you can see now a value is showing keep per square feet. So dead load floor finish we have provided as keep per square feet. Now I'll change from here dead load partition all. Okay, dead load partition all. Now I'll consider we have a partition all here actually at middle point of our structure. So to apply that middle point, I'll use that option, line load, and in Z direction. Okay, so for P1 to P2, or 2 point will be A and B, P1 to P2, or load will be same. Let's say our load will be 0.5 keep to 0.5 keep per feet, and the A point will be okay, I'll go to plan view, and here when G or sure, A point will be here, and our B point will be let's say here. Okay, and as per your requirement you can change this value. Okay, you can change it, then click add, and okay, distance is okay. Click add, and then click apply. Okay, our load is, sorry, its load should be minus. Okay, minus 0.005 minus 0.005. Sorry, I have provided this load 2 times. I'll close it. I'll go here, then partition all, and I'll go for this option. See, already 2 times we have provided this load. Our first load was 0.005 upward and second load is downward. So how will solve it? Or solve it from here also we can do it. So here, then member load, surface load, this load. Again, I can go here, load type. Okay, to see it, now I'll go here, our loads, and here you will see that I have assigned that load multiple times. So you can see how much time I have applied that load here available. Every time I have clicked, every time this load have been assigned. Okay, for 4 times actually. And some loads are working from working in upward direction because we provided the plus value. Now I will close that load first because this value is 0.5. Select and delete. Then I'll close this load also. Okay, done. Now we have only minus 0.5 keep load. We're done. Again, I'll go to our geometry. After partition all, and if you have partition all over the beam here, you can also add it. How to do it? Select the partition all, then go to load definition, select member load, and click here, and it will be also minus 0.5 global. Okay, then click add, and we can also click here. Also you can click here, otherwise we can click here to add, and by clicking here also you can add it. Okay, so what we'll do is 0.5, keep then click add, and by clicking here select this, sorry, select 36, then apply. Again click here, and click here. So everywhere we have provided the same load. Now I'll close it again, and I'll go for the next load, live load floor finish. Sorry, live load floor. I'll provide 40 PSF. Done. Now I'll apply live load proof. Here also I'll apply live load proof. Okay, here I will provide 0.1 keep, that means 100 PSF as a roof live load, then click add. And as this option is available here, or again click here to select it and then click apply. It's done. 0.001. Okay, and also I'll provide you water load here, okay, to show you. Then I'll click here and select the water load. Come here, surface load. Let's say our water load will be 30, 0.03 minus 0.03, add, and it's already selected, or that panel. Then simply click apply and close. So we have defined all types of loads we have assigned previously. Okay, we have assigned previously. Now as we have created model, we have assigned all types of load. Now we are ready to analysis. Now after completing our load analysis, we are ready to assign our model, analysis our model. So to analysis, simply click here, analyze, and then analysis type. This option you will get here also, analysis parameters, and they have another option, calculation. So first of all, we'll go for analysis parameters. So if you come here, this is analysis type. Analysis type. So you will see in analysis type, what is the analysis type. So all of our analysis will be a statistic, and for this 15, 16, and 17 combination, it will be linear combination. Then a structure mode, we'll go for vertical and horizontal member. Here available all vertical and horizontal member. Okay, and maximum length of the member element for automatic division. So if any member length is very high, then it will divide here. Okay, I mean it will get mesh actually. So load to mass conversion. So conversion parameters, if you want to convert anything, conversion direction Z, or if any load available, if you want to convert in any direction, you can do it. So not do it. Then here combination sign. So no need to. They have more option. We will not go for combination sign right now. Then go for result. So for result, actually you can click here, or you can get this option here, result filter. So list of case for what result filtering tab. The following list are used to global filter object display in table. So as per table you'll get it. So simply click here for what load you want to analysis, or for what load you want to get table. Okay, so list of member, list of object, list of finite elements. So I'll not use that right now. Then buckling deformation. So for buckling deformation, consider buckling mode as initial deformation. So if you want to do it, you can take it by clicking here and provide here the coefficient. I'll not use that. I will omit case for a structure with deformation, but at this time I'll not do it. Simply click apply if you have any change, as we didn't change anything, so will not click apply. I'll simply click close. So when you are ready, then I'll click here, go for analysis. Okay, and they have another option, prepare result. Okay, so I'll click here, calculation, and or click here, calculation. Okay, so I'll click here, calculation, and our model are going to analysis. Okay, done. Our analysis have been completed. How will understand that your analysis is okay or not? You will see that your available result, FEM finite element modeling available. Also in the result tab, in heading, you will see available. Okay, so we have completed our analysis. Now we'll go for the result discussion. Now we'll go for analysis. Okay, so for analysis, we'll go for result discussion. So to view result, I'll go here, run result, then here result diagram, result map, detailed analysis. So I'll go here, result diagram. So if you click here, you will get this option here by clicking this tab. you will see what you want to see actually. Okay, NTM, then a deformation, then a stress, reaction, reinforcement, or parameter. So what you want to see? First of all, this is the model, and I want to stop this option. So from this model, if you come here, you will see the many value available here. The value of fz for different types of case. Okay, for different types of case, everything is available here. I will more precise that. To do it, I'll click here. Let's say we'll go for force, shear force. Okay, so first of all, we'll go for shear force fz, then click apply. You'll see the shear force here, right? The available shear force or shear force diagram is available here. Now if you want to go for moment, let's say it will be, if you go for mz, this is the moment I'll uncheck it. Sorry, I'll uncheck is force, then click apply. We'll go for moment diagram. This is mz for our column, then I'll go for my, apply. This is the moment in my direction for our beam. Now if I go here, deform, I'll close it, I'll go here, deformation. Okay, so if you want to see the deformation, you can click here. They have many options. Nodal displacement, then extract deformation for exact deformation for member, and simply click apply. You'll see the member deformation, how the member acting or how the member deforming here. You'll see the deformation. Then now if we go for stress, the available stress is here. So if we want to see, then simply select, let's say select all, then click here. You will see the available stress, the maximum, minimum, all stress is available here. So one by one we'll discuss about it in later, because now we are going for a test project. So I will click none, then click apply. From deformation, uncheck it, then click here and then click apply. You'll see deformation for every node here. Okay, and if you see this showing a unusual, or if this showing a very difficult deformation, then simply click here and click for scaling. Okay, so let's say if we click apply, then scale factor, if I go for 10 and click apply, it's showing very low. If we 1000, okay, so 1000 will go for 5000, go for 3000 here. So here our deformation shape. In this way actually you are able to see your deformation, and here it's showing the maximum is 0.0112 inch. Okay, our deformation. And now also if you want to see the result, then go to view, then table, and from here select the table, say for member, then reaction. Okay, click OK. It will create a table, and here you can see the all member as a table. Okay, again if we close it, and again if you go view, then table. So here reaction is selected, then force, then stress, full table, click OK for that result. And if we come here for different types of combination, we'll see different types of result. Okay, now from here I'll go for, let's say I'll go for dead dot 1.4. You'll see the value for 1.4 here. Okay, I'll close it, again I'll go here reaction, then if I go for FZ, click apply, I'll stop the deformation, and here you can see the table of deformation. Okay, go reaction. In this way, actually, you are able to see residual force, then different types of force is available, reaction in local system, and diagram for linear support, or apply. So you can see here all value is available, and this value is in keep. Okay, so this is the value for FZ. This is value for FZ in keep. So this is the way to find out our value. It's showing for self weight, and if we go for combination 1.4, this is the value. Then if we go for this combination, this is the value. If we go for this combination, this is the value. Okay, and if we double click on a beam, and you'll see the beam geometry, and if you click display, then you'll see the value here. Okay, sorry, displacement, you'll see the displacement of this beam value is available here. And if you go for reaction, the value of reaction will not be available here. If you double click here, and if you go to reaction, you'll see the value is here, and it's 0.74. Okay, so this is the way to find out this value. And okay, we'll learn about some another work. Also, if you click here for, let's say, view table, then if we go for force, reaction, okay, uncheck it, then go for force, then click OK. Here for combo for 1.4, this is the value of force. So you can see total value of FZ, FX, and the value of shear, like that. And they have some option value, then envelope. This is the value for envelope, and this is for global stream, and click here for info. Okay, I'll close it. Actually, this is the main way to analyze your all result or find out your all result. And I hope. And if we go for moment result, this is for moment result here showing. Okay, and this is the scale factor. Actually, if we go for 1, then apply. If we go for 0, if we go for 5, apply. In this way, you are able to change it. Now we'll go for a stress analysis. So to do stress analysis, I'll go here. Then you'll get an option. Detailed analysis, or in my result diagram also we'll get a result, then my result map, they have option. Then we'll go for a detailed analysis. So in a detailed analysis, you can go to stress, in stress, and here I'll go for maximum, then let's say axial, or select all, and then click open, sorry, apply. And here you will see all of our value of stress. And if I uncheck it, if we go here, result, then advanced, so if you want to see the diagram available, sorry, no diagram available here. So actually, as we're analyzing a simple structure, we didn't apply for wind load and earthquake load. so some value will be not available here. Simply now I'll uncheck, sorry, I'll click none, then click apply here also, then reaction or reaction value. Okay, so everything is okay. Go result diagram, and here click uncheck deformation, uncheck stress, uncheck reaction, none, then click apply. Okay, done. Okay, our analysis is okay. After completing our analysis, now we are ready for our design. Okay, now to show our design data, I'll go here. Then first of all, I'll go just simply click here RCC design. Then from RCC design, what we want to see, reinforcement member requirement, click here. Okay, here we're seeing the data, and this is the member, name of the member, and for design member code combination for 18, then click calculate. Close. Now you can see here the total design. Actually, this is the code, 18 code, and if we want to change it, or if we click here, we can select some specific combination. 1.4 dead dot, total 18 case, primary case, then total number of 18, and combination, I'll go for that 3 combination. Okay, for combo we'll go for all of our combo. I'll close it. It's done. Now if you come here, you'll see the value of all members. So this is the value of member 34. Okay, the top reinforcement requirement, then bottom reinforcement has the bottom reinforcement requirement in inches square. Then this is the bottom reinforcement, and this is a distribution reinforcement also. If we go top here for 26, member 26, for this member, this is the top reinforcement. Okay, for 1 feet and 9 feet distance for first 3 feet, and for last 3 feet we need 0.6. and if we provide two number 2 8 word, it will be okay. But we will go for a big project, we'll solve it. And here's the reinforcement for our top reinforcement, that is requirement in middle for 34. This is for 38. Okay, and again beam info, number of beam here. Again go for column. So this is for column, and here's the requirement, reinforcement requirement column. Okay, and this is the reinforcement requirement along have two direction. Okay, they have two direction. The one is along B and another is along H. So yeah, along H we need this reinforcement requirement. So we'll not just will add two, that's two reinforcement, and finally we'll apply this reinforcement. So we need total number 8, 2 and 2 bar. Okay, now this is for RCC member, and if we go for slab reinforcement requirement, if we click here, and reinforcement map with normalized, with click apply, and they have option or play this on 32 for this combination equivalent stiffness, or if you want to click FEM model, you can do it. Model analytical equivalent, you use this option, or if you use this option, I'll click calculate. Okay, now I'll go for slab punching value right now. If they have no issue of slab punching value, then I'll go for slab reinforcement. Select level, slab reinforcement table. Actually, here you can add the provided reinforcement automatic, and then you can go for manual. So I'll take it. Then if we go for another option and for slab record reinforcement, here actually for every point we'll get reinforcement after completing complete analysis actually. Okay, right now we'll not go for it, and when we'll go for our actual analysis, they have many options to select, let's say ground floor, first floor, and for every floor we'll go for this analysis. Okay, and the reinforcement required reinforcement, we have to select all area, or for which area we want to apply reinforcement. Okay, and the minimum reinforcement area, then the many option scale, then service condition, for service condition, then click here. Okay, now I'll go to result, map result. Okay, and from map result, if you go for here, let's say diagram in Z direction, then click apply, you'll see the deformation of our slab here also. Now if I close it, sorry, by clicking here result, then shell and map, from shell and mesh result, you are also able to get result. Okay, so from here, and now from here you can select the combination for which combo you want to see the value. If you right click here, then you can click filter or click table. So for which value you want to see your result, you can select from here as previous, then right click, then you can go for filter. Okay, you can go for filter from here for what you want to use your data, then again click here, then table columns. Okay, for what you want to get your data, and this is for let's say moment, and if you want to get your data for, let's say, this value displacement, then select displacement, and from here load case, you can select also your record load case, or you can go for filter, then extreme parameters data. Okay, let's go for details. Then when it's okay, simply click OK, and here you will see the displacement in Z direction for every point of our slab. You'll see from here. Okay, so I'll close it. Actually there are many ways to find out our data, and if you want to see the shear stress, or here the shear stress, simply click that option and apply. You will see the shear stress value also here, and the another option panel cut. Let's say you want to cut a point to find out the data. So from here also you can do it. Okay, click cut, and here you can define it. So it will not be necessary right now. This is a small structure. Okay, so we're done. Now we'll go for reinforcement design actually. Okay, to do it, I'll go here design, then required reinforcement. Sorry, not for column. I'll go design, then for slab and wall. Okay, and every option is okay right now. I'll go here for this option, and from here our combination is selected. Simply click calculate, and the value of our slab have been calculated. Okay, now we'll go, or we'll show it as a map value. So to see it with description, okay, no need to see it. Okay, to see this map value, this value is a map value. Okay, I'll go for this option. Let's say map, then only click this option, then click open in new, yeah, and then click here, and from scale select 256 scale, and when everything is okay, simply go for apply, and you will see a value is here. And okay, if we click value, apply, you'll see the value of our reinforcement, record reinforcement here. Okay, also if you go for -x, then -z, or number of bar, then click apply, you'll see for every section the number of bar or required bar is available here, where how much reinforcement requirement. Actually we'll discuss about that later. This is the required reinforcement, and for minimum reinforcement, if we click here, this is the requirement of minimum reinforcement actually. Okay, and actually if I take the mouse, we are seeing that everywhere we need 0.0 to 4 inches reinforcement everywhere. Okay, now if we go for plus x, I mean in x direction, or plus, then click here, and if we go for y direction, minus y direction, this is the required reinforcement here also. And number of bar or top bar or bottom bar. Okay, this is the direction for bottom bar in every direction, and in top we don't need any reinforcement right now. Take off. Okay, so in our next lecture, actually if you take your mouse and for a positive situation, we can see a reinforcement here. In support we need very little reinforcement in support, see here. Okay, and if we go with map value and then click apply, here you can see in support we need a reinforcement. And if we go for y, here in y direction only, in y only we need reinforcement in support. And in this way, and if you go for spacing, you'll see here 4.7, where how much spacing is required, it's showing. So when we'll go for the maximum design process by using a big model, then we'll cover everything in details. Thank you very much.